go to the theory and we'll try to understand different concepts related to operating system. So this is the definition that we have seen yesterday and day before, that what do you mean by an operating system. So it is written is operating system is a program that act as an interface between a user of a computer and the computer hardware. So it is nothing but either, so it acts as an interface between user of the computer and computer hardware. So yesterday also I told you that if any user, so if we have some sort of user available and this particular user want to access or want to use the hardware, so what it has to do is it has to go through operating system. So operating system is acting as an interface between user and the hardware. So let's say if we have a user and this user want to use the hardware, underlying hardware. So how this user will use it? It will use it through operating system. Now, how this user will interact with the operating system? So it will have some sort of application, right? Some sort of application. And with the help of these applications, actually user is interacting with the operating system. It is not like directly it will touch something into the operating system and it will interact. No, it has some sort of applications, like if we want to interact with this particular operating system, so we have GUI available, right? And in the GUI, we can have different icons. So we'll just, if we want to open something, we just double click the icon. Or if you want to go through the file system, I have to open the folders and all, right? So all these are nothing but some sort of applications which are available, and through the application user interact. So user will interact through these applications to the operating system, and this operating system has an integral part which is called kernel. This particular kernel will is, you can say, the soul and the heart of operating system. And actually this kernel, which is the part of operating system, will convert the request of the user to the hardware understandable language, and then it will send this particular information or this particular request to the hardware. Once the hardware will understand that or will do the process of the request, it will give back the result, and this kernel will provide this particular request to the operating system level, and this operating system will provide the result to the user. So this is how the hierarchy takes place. So this hierarchy is in that particular way, right? So this is the hierarchy of your whole system, that how it works. Okay, what is the second sentence? It is written like, in simple word, we can say that operating system turn ugly hardware into beautiful abstraction, right? So if somebody will give you the hardware, so the hardware will looks very miserable to you. Miserable means if you have knowledge of the hardware, that this is the processor, this is the RAM, this is how your motherboard look like, then only you can understand, right? If you doesn't understand, it look like some hardwares which has different wires available, which have different gadgets available, and you cannot interact with it. How you can interact with the hardware if the hardware is given to you? So definitely we should have a sort of interface which can do that. And this interface is nothing but the operating system, which will make an abstraction. Abstraction means it will tell you that what are the memory we have, what are the of CPU we have, what is the configuration of the CPU, how much hard drive you have, what is the company name of the hardware. All those things will be shown to you. So it will give you the abstraction. Abstraction means the full idea or full information they will hide and give you something that you require. Okay. So physically you cannot see those hardware, but you can see that these are the hardware that are available with us. So here in the example, if you'll see, we have the hardware, and it is shown like there is some ugly interface with the hardware. That particular interface, the operating system will convert into beautiful interface, and through the application program, any user, through this application program, any user can interact. So any user can interact through this particular application, and this application will interact with the interface provided by the operating system. This operating system will change, and then through the kernel, through the kernel, it will change to machine understandable language, and then this process will take place again. So this is how your operating system is. Yesterday we have seen the two goals of operating system, that why we create operating system, what are the usage of operating system, right? So we create the operating system. First thing, we want that user will use the operating system properly. So the first thing that we are looking for is the convenience. How conveniently any user can use the operating system. This is the first goal of any operating system. So I told you the operating system about this DOS operating system, which is shell based operating system, where we have to give some sort of command. Okay, and through the command only we can interact with the kernel. So as I told you, kernel is the integral part, heart and soul of the operating system. So with the command only, it will interact with the kernel, and kernel is going to interact with the hardware related to the related to any of the computer system. So here we doesn't have any interfaces related to mouse. So here we'll not use mouse, right? In the DOS operating system, we use keyboard, we give some commands, and this kernel will interact with the hardware based on the commands that has been given through the shell. Now to make it more convenient, this operating system has been came into the picture, which yesterday I told you that we have Windows operating system. Then we have a Mac OS. Then we have Unix kernel or Unix OS. And the open source version we have Linux. Well, Linux operating system is your open source operating system like this. So we have many sort of operating system available with us, and we have some more operating system. It's not like only these operating system are there. So most of the operating system is Linux based and the Unix based operating system, but mainly this Mac OS and Windows OS has been made with the goal of convenience. So to make it more convenient, this operating system has been developed, and this is the first goal of the operating system, of any operating system, whether the operating system is of desktop or server or your mobile phones. So whatever operating system we use in any of the computing device, the main purpose of the operating system is convenience, that how conveniently we can use the hardware of the computer system, how we can manage the file, how we can open our processes, how we can do the multitasking, right? So all those things is come to convenience. The next thing is efficiency. So efficiency matters to the system, like mainframe, okay, like supercomputer, where efficiency is at most important. Now come to computer system structure. We know the structure of the computer system. We are just revising it again. The computer system can be divided into four components. The first component will be your hardware, which is a bottom hierarchy of the computer system, which provide basic computing resources like CPU, memory, and I/O devices. And then we have operating system, which control and coordinate use of hardware among various applications and users. So it will control and coordinate use of hardware. So how these applications are using the hardware will be controlled by the operating system and will be coordinated among those programs. So if we have open 10, 20 programs in our computer system, so how all the program is running at a time, because we have only one CPU available, or let's say four core or 8 core CPU available, but we have number of processes or number of programs that are running, that a user has run the program, but there are many other program which is running in the background. So how all the program is running when my CPU is limited? So that is the CPU management will be done by the operating system, and we doesn't have to bother about it because operating system will take care of all those things. Next component of your computer system is application program. Defines the way in which the system resources are used to solve the computing data of the user. So definitely we have different application program like word processor, like if you will install the Microsoft Office, let's say 356 or Microsoft Office 2018, 19, whatever it is, the latest version of it. If we are installing some sort of compilers, let's say the Python compiler, JavaScript, or Java related compiler, if we are installing the web servers or web browsers, let's say we have installed Google Chrome for that. So that is nothing but the application program. Database systems, let's say we are installing the Oracles and all. We are installing some video games. So all those comes under the category of application program. Defines the way in which the system resources are used to solve the computing problem of user. So user, if user we doesn't have, or let's say I am the user of the computer system and I doesn't have any of the application program. So what is the use of the computer, right? So what is the use of computer for me? I should browse internet. I should, let's say, write something in the word processor with the help of that. I should do some sort of programming with the help of the compiler. I should store the data with the help of the database, or with the entertainment I used to play the video games. So all those things are there. That's why I am using it. Otherwise, it is of no use. The next component, or the next part of the computer system is user. Either people is using the computer system, or machine is using the computer system, or other computer is using the computer system. Okay, so people is very understandable. What about machines? So machines also, see, different machines we have, which is using these operating system in order to interact with the application program and other computers also. Let's say one computer is interacting with another computer. Let's say one computer has is a master, another is a slave. So slave is interacting with the master, right? So one computer is interacting with another computer, again with the help of application program. So the hierarchy of the computer system look like this. So at the very bottom, we have computer hardware, which are available here. So this is the very bottom part of it. It is my hardware available. Then we have the operating system, and the part of the operating system is kernel, as I told you. About the kernel, we'll see in that in very detail. Then we have system and the application program, which are running like compiler, assembler, text editor, database, and many other and number of application program we can install. And we have users which will use it. So these users can be the people, can be the human being, right? Can be the machine, or can be the computer itself. Now let's see what operating system do. So the first thing is user want convenience, right? So user need the convenience to use the operating system. So a user need the convenience first of all. So operating system should be easy to use and it should give good performance. Means convenience and the efficiency. So don't care about resource utilization. Who don't care about the resource utilization? The user who is using it doesn't care about resource utilization, that how an operating system is utilizing the resources. That thing will be done by the operating system. So the resource utilization will be done by the operating system. How easily we can use the hardware, this is also done by the operating system. How my hardware will give the good performance, this is also done by the operating system, right? But shared computers such as mainframe and supercomputer must keep all user happy. How let's say we have the servers, right? So in, let's say if you have a Google server or Facebook server or any of the servers which we use as a multi-user. So if these servers will not going to serve you, means if you want to open your mail and it is taking a lot of time to open this particular mail, so definitely you will not use that particular services, and you will use other mail services. So, but they are looking for efficiency, that how efficiently we can use the resources so that we can fulfill the requirement of all the users. That's why it is saying that in some shared computers like mainframe, supercomputer, or server, must keep all user happy. And how it will keep all user happy? By utilizing all the resources and by giving all the hardware resources to all the all the users. Users of dedicated systems are, such as workstation has dedicated resources, but frequently use shared resources from servers. So definitely the shared resources, the concept of shared resources comes when multiple users are using it or multiple applications are using our system. Workstation means my desktop or my laptop is the workstation, which has some dedicated resources. But if I'm using some shared resources with the help of the servers, so let's say there is a server and this particular server is used by many users. So we have users and all these users are using this particular server. So definitely, because it has only, let's say, the bunch of hardwares available, let's say we have in the server, let's say 16 core CPU is available, right? So if we have 16 core CPU available, means 16 user can, or 16 application can interact very easily. So it will do like that. Who will? The server will do like that with the shared resources. It will share the resources, and it is the responsibility of the operating system to manage all this. Now, the next point is handheld computers are resource poor, optimized for usability and battery life. So definitely, if we have the computer available with us, let's say my laptop or my iPad or my computer system. So here, the responsibility of the operating system is to optimize the usability so that the battery would be used less, or we can use less battery for that, so that we can optimize it. Let's say if I'm not using the computer system, it will go to the sleep mode. If I am not using something, it will try to optimize it or try to harvest the energy of my system. Then we have some computer where we have no user interface, such as embedded computers in devices and automobiles. So let's say if we have some embedded embedded system, let's say we have uh, hardwares like let's say you all see access controls or switches. So all those, or the routers, all those devices doesn't actually very little user interface is required or no interface is required. So on those type of embedded system, uh, the user will not interact with it, or user cannot directly interact with it. Okay, so depend upon the event, it will do the processing. Like in automobile system, or in automobile systems, there are the operating system available, but these operating system will not be taken by or not be used by the user. Okay, depend upon the different events of the automobile, it will act. So there are embedded system means the software or the operating system is there in these system to do some dedicated work. So there are some dedicated work which is defined based on the event, and once the event triggered, this embedded system will do something. Or let's say if event one will occur, then we'll do that. Event two will occur, then we'll do. So pre-described event and the actions are there with the help of the software or the operating system that will put into the embedded systems. So embedded system has, you can say that it is the hardware which has the dedicated software, right? Embedded system is nothing but some sort of hardware which has the dedicated software which will work for that particular hardware only, and based on the events it will trigger. So this is about your operating system, that what operating system will actually do. So, okay. We have some, how we can define the operating system. So the definition in one line, we can say that it is an interface between user and the hardware. But we have some more related to the definition, and that is here. Like operating system is a resource allocator. Yesterday we have gone through that what is the responsibility of the operating system. So one of the responsibilities is resource allocator. And what happen when operating system will allocate the resources? It means it will manage all the resources, and it will decide between conflict request for efficient and fair resource use. So if we have, let's say, two or three program available, which want to use the same amount of or same hardware, so it will resolve these conflict or these ambiguity in an efficient and fair manner. So all the application that will be submitted into the computer system should be means efficiently and fairly taken care of. That is the responsibility of operating system. What is an operating system? It is a control program. It controls execution of program to prevent errors and improper use of the computer. So you can say that operating system is nothing but the control program, a sort of control program whose responsibility is to control execution of program to prevent error and improper use of the computer. Means properly the program should execute, and properly program should execute without the error. So that is the responsibility of the operating system, and we can say that operating system is a control program also. So the one program running at all the time in the computer is kernel. So kernel is running in the computer system, and this is also a, as I told you, is a program, and it is also a control program. It is a heart and soul of the operating system, kernel, and it is always running into the computer system. So once you on your computer system, kernel is running. Everything else is either a system program. So either we have the system program, which is the program related to the operating system which is running, or application program. So these type of two programs are always running into your system. Either it will be a system program or it will be an application program. So what is a system program? Any program related to the operating system is called system program. And other programs like your word processing, your browser, your web server, your compiler, all those other programs are called application program. So in your system, either of these should run, or it should running. Okay. And in the system program, you can say that many device drivers like we have display card, we have Ethernet card, we have different hardware attached to it. Let's say if I'm using the keyboard of it, right? Or I'm using the mouse or the keyboard. So it has the associated device drivers which will control the hardwares and all. And all these device drivers are nothing but the system program. So these are one category of system program. There are different other category of system program, means dedicated, some dedicated functions are there, which are also comes into the category of system program. So this is all about the definition of the operating system. Okay, the responsibility. So we have discussed it earlier. The responsibility of the operating system is resource allocator and resource manager. And what are the resources we have? So we have resources. So let me tell you about what resources we have. So the first resource we have is CPU. Okay, how we are utilizing the CPU. And CPU will be utilized by any sort of process. Any sort of process. Process is nothing but the instruction under the CPU for execution. Second is memory. Memory is nothing but your main memory. What is main memory? RAM, random access memory, that will use. And this particular RAM is not only the RAM. This particular RAM is, let me tell you what is this. This particular RAM is DRAM. Okay, this particular RAM is DRAM. DRAM is dynamic random access memory. I'll tell you about it. What is static random access memory? What is dynamic random access memory? But it is a memory. The third resource that has to be handled by this operating system is your IO, input output devices. And there are different categories of input output devices. So what are those? So we have like keyboard, mouse, display. Display is your screen or your console, right? Then we have printer, and we have your disk. It's called hard disk, or it is your secondary memory. Okay. So what we are going to learn in the operating system is that how these resources will be allotted, or these resources will be given to the program or to the user, right? Because user is interacting through the program. So we can say that these resources are available to the program, that will see, and how we are managing those resources, so we are going to see that how we can do process management. We can see memory management. We can see disk management. So all these type of management we'll see one by one in the operating system courses. So process management is nothing but it will come here with the CPU. Then we have memory management, and this memory is nothing but your main memory. And we have disk management, which is nothing but your hard drive. Okay, that's how we are going to manage it. So all those things we'll see in subsequent classes. We know that, right? That the basic unit a computer system will store is a bit. So in the form of a bit, the computer system is going to store anything, any data, whether it is a text file, or it is a video file, or audio file, or your picture, or anything else, will be stored in the form of bits, either 0 or 1. So a bit can contain one of two value, either 0 or 1. All other storage in a computer is based on collection of bits. Given enough bits, it is amazing how many things a computer can represent. Can represent either number we have, or it can represent letters, or it will represent images, movies, sound, documents, and programs. A byte. What is a byte? Byte is nothing but 8-bit is called byte. And one most computer, it is the smallest convenient chunk of storage. So in most of the computer, we represent that in a byte level, we are storing the data, but actually it is storing in the bit level, but sometimes we say byte. Okay? It doesn't matter. Like one character, it is of 1 byte, right? So we say that this byte or byte is the smallest chunk of storage, right? But actually bit is the smallest chunk of storage. For example, most computer don't have an instruction to move a bit, but do have one to move a byte. So we have many instruction transfer request in which we transfer with the help of byte, not bit. A less common term is word. So we have word also as a common term. We have the first term is bit, then we have byte, and then we have word, which is a given computer architecture native unit of data. A word is made up of one or more bytes. So how many bytes are there? It is depend upon that. So one byte or more than one byte, we can say it is a word. For example, a computer that has 64-bit register and 64-bit memory address typically has 64-bit, which is 8-byte word. So it depend upon your internal architecture, it depend upon your internal hardware, that how your register size is and how your memory addressing is. Based on that, this word will be decided. So our computer execute many operation in its native word size rather than the byte or bit level. Computer storage, along with most computer throughput, is generally measured and manipulated in bytes and collection of bytes. So we know that what is kilobyte? Kilobyte is nothing but 1024 bytes are called 1 kilobyte, right? Then we have megabyte, which is 1024 to the power of 2. Then we have gigabyte 1024 power of 3. Then we have terabyte 1024 power of 4. Then we have petabyte 1024 to the power of 5 bytes. Then we have, I think, zettabyte and yottabyte available. Subsequently, 1024 to the power of 6, 1024 to the power of 7. So this could be this could be to the power of, okay. So the representation, we all know about it, right? Okay. Now, computer manufacturer often round off these numbers and say that a megabyte is 1 million byte and the gigabyte is 1 billion byte. So somewhere that is also written like 1 gigabyte is 1 billion and 1 megabyte is 1 million byte. Networking measures are an exceptions to this general rule. They are given it bits because network move data a bit at a time. So one bit at a time. In the network, we move the data like in the form of 0 and 1 signal. So if signal is high, it is 0. If signal is low, it is. So if signal is high, it is 1. If signal is low, it is 0. So I don't know what is the signal amount is, whether it is a 2 volt or somewhere. And here it is 0 volt. So if we have 2 volt signal, we say it is a 1 byte. If we have 0 volt signal, we say it is a 0, 0 byte. Or 0 bit, sorry, 0 bit and 1 bit. So this is how we transfer in the network.